Hello everybody and welcome to bowtieteacher.com. I'm Rob and in this video we're going to be looking at geometric series. Let's get started. So a geometric series is one in which the difference between each term is not the same each time. So in an arithmetic series is going up 3, 6, 9 or 1, 4, 7 for example, whereas a geometric series would go up in powers. So if we have a look at the most basic example where we have 2, 4, 8, 16, ... Okay, you can see that the difference between each term is not the same each time. So in this case we would not be able to use our methods from the arithmetic topic. But there are some similarities in which we have A, which is the first term, and instead of D for the common difference we would have R, which is the common ratio. Okay, so in this case we're going up in 2, then 4, then 8. So it's going up multiplied by 2 each time, or it's going up in powers of 2. So our nth term can be represented by AR to the power of n minus 1. So for example, the first term in this case, A, is going to be 2. The second term would be AR, which is 2 times R. In this case, the second term we can see is 4, so 2R equals 4, so R, the common ratio, is 2, as we found before. The third term would be AR squared, because we have the third term, n equals 3, 3 minus 1, that gives us the 2 in the power. So AR squared would be 2 times the common ratio squared, which gives us 8. So we would be able to predict, for example, the fifth term, AR to the power of 5 minus 1, would be 2 lots of 2 to the 4. And 2 to the 4 is 16, so the next one in the terms would be 32. Now, in the exam, they won't be giving you the series and just asking you for these. They will be giving you the third term and the fifth term and asking you to work out what the common ratio is, or if something's part of a sequence, for example. So let's take a look at a question like that. So we could have, in this question, they might say the second term is 4 and the fifth term is 32. Without having any of this information here. They would just give you those two pieces of information in the question and ask you to work out maybe what's the first term or what is the common ratio between them. So in this case we would have to use simultaneous equations because we have two unknowns. We don't know what the first term is or the common ratio, but we do know that the second term, which is represented as A, R, and n is 2, so it's going to be 2 minus 1 is 4, and A, R to the fifth is 5 minus 1 is going to be equal to 32. So our two simultaneous equations that we have are AR equals 4 and AR to the power of 4 equals 32. Now where do we go from there? Well, we can substitute in for A or for R to find either of these, or we can just divide these two equations and we will be able to get these straight away. So if we do 2 divided by 1, we will have AR to the power of 4 over AR equals 32 over 4, like so. We can cancel these powers, so AR to the power of 4, the A's cancel, R to the power of 4 divided by R is R cubed, and 32 over 4 is 8, so R is the cube root of 8, which is 2. So we found the common ratio, and we can now find A by substituting into, say, 1, substitute into equation 1, we have A times R equals 4, so A is also 2. Okay, so this is the same sort of process in which we use simultaneous equations as we do in the arithmetic topic. Let's try and hop over to bowtieteach.com and we can go to the level 8 tab and look at some quadratic sequences here. So If the third term in the sequence is 27 and the fifth term is 243, find the first term and the common ratio. So let's just do a new layer here. The third term is going to be AR 3 minus 1 in the power is 27, and the fifth term is 243. So AR to the 5 minus 1 is 243. So we'll just rewrite these as AR squared is 27 and AR to the power of 4 is 243. Divide equation 2 by equation 1 and we get AR to the 4 over AR squared is 243 over 27. Cancel the A's and the R's and we have R. The R squared will become R squared on the top. R squared equals 243 over 27 if we're not sure. 243 over 27 is 9. So R is going to be 3. Okay. We substitute back in. A times R squared is 27. So A is 27 divided by 9, which is 3. So our first term is 3, and the common ratio is also 3 in this case. So we can check this by substituting back in and seeing if this kind of makes sense. Our first term is 3. The second term would be A times R, so 3 times 3, 9. The next one, AR squared, 3 times 3 squared is 27. 3 times 3 to the power of 4 would be 81. 3 times 3 cubed, and 3 times 3 to the 4 is going to be 243. So we kind of see this progression here in a geometric sequence. Okay. Have a look at another question. Just check that for 3 and the common ratio was 3. Correct. So if we have another look at a question here, then the second term in the sequence is 15. So the second term would be AR, and the fourth term is 135. So AR, the fourth term would be AR cubed is 135. We can divide these two. AR cubed over AR equals 135 over 15. Cancel these and we have R squared is 135 over 15. Which is 9. So our R will be 3, and we can substitute in for AR equals 15, so our first term is 5. Check that against the app. We have 5 for our first term and 3 as the common ratio, and we've got that correct. Okay, so I hope that was helpful. If you need any more help, please leave a comment below, or you can email me at mrwakelin@bowtieteacher.com. Have a great day and good luck in your exams.